Good morning. This is Scott. So, this is a brief video. It's part of the series that I'm doing on Bayesian statistics and decision making. So, I hope you join me for Bayes04, where I introduced my intent for the series. Please see that brief 3-minute video. We're already up to Bayes04, and so let's dive in. So, decision making under uncertainty is the first thing that we're going to cover. We're going to do an example. Should you carry your umbrella today? We'll talk about subjective assessment of probability, expected payoffs, and some tables there, and then another example as well on advertising. All right, so decision making under uncertainty. So it turns out that all decisions are made under uncertainty, right? So can you name one decision where you were 100% sure of an outcome? I haven't. So if you have, please leave me a comment in the comment section of this video. I'd love to know what decisions you're making um, where you don't have any downside. So the second part is uncertainty in the event that happens or in our mind. So the event, we talked about that. Let's suppose that we flip a coin. Is the uncertainty in the coin or is the uncertainty in our mind? If we roll a pair of dice, is it in the physical dice or is it in the way that we view the dice and what we know about dice, having rolled dice before? Or maybe it's whether the Cowboys are going to win on Sunday. Is it in the team or is the probability in our minds? If it were the team, probably everybody would carry the same likelihood that they're going to win. Those that have been jaded by the Dallas Cowboys may not have the same positive look on that event. So, and then really, if we look at it, probability is the only rational way to approach a decision. We make decisions all the time on emotion, but if we really want to improve our decision-making process, maximize the anticipated payoff, we can use things like Bayes' theorem and probability. So today we're going to talk about probability and payoffs. So personal example, maybe you're deciding whether you should take your umbrella to work or not today. And you've got on your brand new silk shirt, and this shirt actually costs you 90 bucks. And so if you wear it and it rains, it's going to ruin it. So you're trying to assess whether you should wear it or not. I'm sorry, take an umbrella or not. So the top row here represents the cost of carrying an umbrella. So I don't know about you, but I hate to carry an umbrella. So if it's not going to rain, I only carry an umbrella when it's likely to rain. But here, let's look at this example. So for me, it's at least a $3 nuisance charge, if I end up having to carry an umbrella. So that's represented by this top row. Carry an umbrella -3. It doesn't matter if it rains or not. It's still a pain to carry that umbrella. All right, so now the second row. Do not carry the umbrella. And so if it rains and we don't carry it, again, that shirt is ruined, and there we go. That's a major cost. If it doesn't rain and we don't carry it, big deal. Zero cost from that. And so, by the way, this payoff table is from the, and this is called a payoff table, and this is from Robert Winkler's book that I've mentioned previously. All right. Let's look at the next slide. Okay, so subjective probability. So now we have the payoff table. We know what it basically is going to cost us. We created that table, but the big deal is whether it's going to rain or not, right? So what are the odds? So I don't know about you, but my weather app is horrible. So maybe I think I could do better by looking outside. Is it even cloudy? I don't know. What does the Farmer's Almanac say? So these are different ways to assess my probability of rain. Again, it's in my head. It's not in even in the weather app's head. It's what I think in the end. So the Farmer Almanac, if you're familiar, it's basically shows every day for the last 100 years of when it's rained or not. Or maybe I just go with my gut feel. Am I feeling lucky? Maybe I'll go with that and decide whether to carry it. Or maybe I have a lucky charm, and when I have my lucky charm with me, things go my way. So maybe if I carry it, I won't have to carry an umbrella. Or maybe I want to leave it up to the fates. So if I flip a coin and it's heads, then it's not going to rain, and I'm not going to carry an umbrella. Or maybe you have a method. But let's suppose in the end, I look at the app, I look outside, and I determine that there's a 10% chance of rain. How can I use that information with that payoff table? So here, this is it. So I determined there's a 10% chance of rain. The payoff of carrying an umbrella, again, we said is minus $3. So it doesn't matter whether it rains or not. That is the flat payoff, regardless of the outcome. So the payoff not carrying an umbrella is going to be that $90 times the chance of rain, which is 10%, plus 0, because if it doesn't rain, the cost is 0. So the payoff of not carrying the umbrella is a minus $9. So that is 3 times the cost of carrying the umbrella. So in the end, what I want to do is I either want to carry the umbrella or change my shirts. All right. So let's look at another example. Let's suppose that your company is trying to decide whether it should launch an advertising campaign. The reason you're doing this is because your competitor is likely to launch a new product. You've kind of heard some rumblings of that. And so you want to have a strategy in place to do something in case that they do. And you really have to do this campaign before they launch the product. So you're considering 3 different options, and those options are this top row, no advertising at all. The second one, you could do a minor ad campaign, or thirdly, you could do a major ad campaign. And here are the payoffs in those events with the response of whether the competitor launches or does not launch. So if the competitor introduces a new product and you don't do any advertising, your payoff is only $100,000. However, if you don't spend the money for advertising and they don't, the payoff looks really good, $700,000. If you do a minor ad campaign and they introduce a new product, you go from 100 to 300, which is good. But if they don't launch, you go from 700 to 600. And then if you launch a major ad campaign and they launch, then you go from 100,000 doing nothing to 400,000, which looks pretty good. But if they don't launch, you go from 700,000 to 500,000. So what should you do? Well, you need to look at the probabilities of those events. And so let's suppose that you do some research based upon this particular competitor and their history, and you determine that the probability that they're going to launch is 60%. So we can use that 60% along with this payoff table and determine the optimal decision based upon revenue. So again, the probability is 60%. If they don't introduce a new product, then what we have for the top row, the no advertising row, is that 100,000 in this cell times 60%, right? That's the probability that they're going to launch. And then 700,000 times the remaining 40%. So if we get 40% by taking 1 minus this, probabilities sum to 1 if you use the entire sample space. And here, they either launch or don't. So that is a sample space. And you get a payoff of 340,000. So we do the same thing for the second row, plug in the 300,000 and the 600,000, and we get 420,000. This is just done in Excel below. And then the major is the 400,000 times the 0.6, the probability that they will major. And then the 500,000, that they don't launch times the 0.4, and we get 440. So in the end, the greatest payoff is to launch a major ad campaign with the expected payoff of $440,000 compared to 420 or 340. Okay, so again, this is expected value or expected payoff, and yeah, I could say a lot more, and we will say a lot more in future videos. I'd like to hear what you're thinking about this. Please leave me a comment in the comment section of the video. Also, if you can join my channel, just go into YouTube, type in Scott Burke, and that you can join my channel that way. I always appreciate a like, a thumbs up if you like some of the stuff that I've created. And then I've created this playlist, this Bayesian statistics, prediction and prescription, specifically for everything Bayesian. This series is in there, but there's a lot of other stuff in there as well, including some stuff in R and Python that I'm creating as I go along. So I'm trying to balance these. Anyway, hope to see you again soon.